Hello, participants. Now we will be discussing another situation that is related to that is also known as chi-square test, or the other name is the crosstab analysis. So for that, I have shared uh, the slide. Right? So the next part that is related to uh, crosstab analysis. Right? What do we mean by crosstab? Crosstab means the cross tabulation. So when we discuss the cross tabulation, it always means that there is there are two variables that we are considering, and one variable is on the one dimension of the table, and the another variable is on the other dimension of the table, right? So we will be having one variable here like this. So we will be having the different categories of one variable here and the different categories of the second variable here. So that's why this table is known as cross tabulation. Means if we have to interpret this value, this dot, so we have to look for both the directions, means in this direction as well as in this direction. Suppose this variable is v11 and that variable is v21. So this value would be that where the v1 is taking a particular value v11 and v2 is having a particular value v21, right? So this is for that. So that's why this table is known as cross tabulation. And the main objective of this table is to examine whether the two attributes are independent or not. So that's why this is known as a chi-square test of independence, right? And um, how this is different from the main chi-square test, right? Chi-square test can be parametric, chi-square test can be non-parametric also. So here in this test, we will be considering the non-parametric part, okay, where we examine whether the two attributes are independent or not, right? So obviously it requires some assumptions. We will be discussing those assumptions here. Then only a normal chi-square test would be converted into chi-square test of independence, right? So what is the hypothesis? This hypothesis is two attributes are independent. Means there is no association between two variables. And H1 is two attributes are related, two attributes are associated, right? Here we will be examining this. So what is the assumption? Assumption is the total frequency of sample size should be large, right? The thumb rule is it should be greater than 50, and each expected frequency should be greater than uh, 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 greater than 5. And how it is being done? It is being done by comparing the value of observed frequencies with the expected frequencies, right? So, uh, that, I will take an example here, right? Suppose here, this is the case. Suppose we want to examine whether getting pass in the examination and the gender are related or not, right? So what is the hypothesis that we are going to examine? H naught is the one attribute is gender, and, and the other attribute is getting pass or the result or qualify are independent or not, right? So H1 would be they are independent because H1 assumes no difference and H naught assumes no difference. So H naught is independent and H1 is they are related or they are dependent. Right? So here on one dimension we have gender. Suppose the gender is female and male. And the second one is the result. Right? The person is pass or person is not pass. Right? So here the values would be given. Right? Suppose the values are given as O11, O12, this is O21, this is O22. Okay. And this total would be R1. Row sum, this is R2. And the column sums are C1 and C2. And N is the grand total. So these are the observed frequencies. So OIJs are observed frequencies. Okay. Then we compare these observed frequencies with the estimated or expected frequencies. This is EIJ. EIJ means for EIJ, this would be uh, sum of the ith row into sum of the jth column divided by n. Right? So what would be the EIJ value here? Here I am demonstrating that. So this would be E11. And for E11, what is the row sum? R1. And what is the column sum? That is C1. So for E11, we will be having R1 into C1 divided by N. In the same way, this value is E12. So for E12, row sums remains the same, that is C1, and the column sum would be C2. Right? Sorry, I have written here as C1, so this would be C2. Okay, so R1 into C2 divided by N. In the same way, E21 is this value. E21 would be C1, or it would be R2 into C1 divided by N. This is R2 C1 divided by N. And the last value, that is E22, it would be R2 into C2 divided by N. Right? These are the expected frequencies. Now we compare the magnitude of OIJs and EIJs. If the difference is negligible, difference is insignificant, right? So uh, actually, when we consider the estimated or the expected frequency, it is as per S naught to be true. Means these frequencies or the estimated or expected frequencies are being estimated under the condition that they are independent. Okay, right? So if the difference is insignificant, it suggests that the two attributes are independent. Two attributes are independent means H naught cannot be rejected. Okay, right? Otherwise, we will be rejecting that naught. So for that, we estimate the chi-square statistics with the formula. So this will be repeated for all the cells. So it would be OI minus EI whole square divided by EI. Okay, and this will follow chi-square distribution with degrees of freedom R minus 1 into C minus 1, where R is the number of rows and C is the number of columns, right? So here it is there also the chi-square statistics would be the comparison of observed value and the estimated values divided by EIJ, just to just to normalize that. It follows the chi-square distribution with these degrees of freedom, right? So there, here all the values are there. So we will be examining whether they are independent or not, right? So for that, I'm introducing a new case. So this is the case related to mutual fund, right? Let me read the case that marketing department of AMC designed a promotional campaign for the new mutual funds, right? While the mutual funds are suited to both household and the business market, AMC wish to determine, means they want to concentrate on executive willingness to buy its mutual fund, right? Management particularly wanted this information in these cases, right? The reaction of the business houses of various size, right? And the second case is the impact of familiarity with X on the willingness to buy, right? So we will be discussing this situation here, okay? So we will be discussing this situation here. So this is the part that we will be discussing in this case, that they want the relationship between these two things, right? Impact of familiarity of company X on the willingness to buy. Okay, right? So here, as further that if we consider the data, the willingness to purchase was measured on 11-point scale. So one variable, that is the willingness, is a metric variable which is measured on extended Likert scale, that is the 11-point scale, and the other variable is familiarity, right? Which is a categorical variable with three categories: one, two, and three, right? So here one variable is metric and another variable is non-metric, right? If both the variables are metric, then for the relationship purpose, we can always use um, the regression analysis. So this case we would be uh, discussing here. So now, just to make that point, since the relationship word is being done, so this test is also a type of to examine. One objective is to examine the relationship between attributes. Now, as the name suggests, attributes must be non-metric or categorical in nature. So this is the situation for which it is a better employed. Okay, so this is the case, right? And this case we will be discussing here. Now, I am again using going to the case, right? So that one thing should be discussed first, and that is, as you see here, this willingness is on 11-point scale. So this is metric. And we have discussed that this test is more effective if both the attributes are um, non-metric or categorical in nature. And we all know that we can always convert a metric scale into a non-metric scale. So we will be converting that willingness, which is on 11-point scale, into different categories so that the comparison would be in between categories, or the relationship is in between the categories, right? So this we will be discussing here. So at present, as you see here, the willingness is on 11-point scale. Means this is extended Likert, so it is metric in nature. Now we will be converting this willingness into a categorical variable. Let the name of that categorical variable is willing cat. Right? Cat means categorical. And we will be converting it into two or three categories. Suppose we decide that we will be converting that into three categories, denoting low willingness, medium willingness, and high willingness. Since this is to be converted into the three categories, so we decide that um, since there are 11 points, so one group um, must have the 3 point and other two groups have the 4 point, right? So suppose we have decided that from 1 to 4 would be put into the low category part with the code 1. So this is the variable that is willing. And here we are having the attribute or the variable as willing category. And so this is the willingness, right? We will be converting that. And after that, the second category would be from 5, 6, 7. The 3 points are there into the medium willingness category with the code 2. And the next one is 8, 9, 10, 11. Right? So this would be high willingness with the willing category 3. Right? And after that, we will be using this test This is the high willingness, right? So when we apply the cross type analysis or the chi-square test of independence, the two attributes that we are taking here is familiarity, which is already having the three categories as per the data, and the other one is willing cat that we will be developing here, right? So first we will be doing this through the spaces. Here we will be using either VLOOKUP or if that is available in Excel. And spaces also have an inbuilt function that will be used for this purpose, right? So I will be showing you that only. Okay. So this is the data set that we have just introduced. And for this data set, since we have to develop a new variable with the name willing cat, so for that, here I am introducing a new button that is the transform. So we go to the transform. Here we have two interesting menus or options that record into the same variable. If we do this record into the same variable, then original variable would be overwritten. Means original variable would be lost. So this is never recommended. So we will be going to use record into different variable. So record into different variable means the original variable that is the willing would remain the same, and we will be introducing a new variable with the name willing cat, right? So that there won't be any impact on the original variable. So if we click that, so this is the dialog box through which we will be performing this. So here on the left pane, we have all the variables, that is the willingness, and um, we will be selecting this variable that is a willing category. Now it is demanding us the name of the output variable. Suppose we put the name as willing cat. You can take another name also. So this is the willing category, and we will be clicking the change. So this is there. So a new variable would be created, a new will be recorded through willing to willing cat. Willing is the numerical variable or the input variable, and willing cat is the output variable that we are converting. Now we will be selecting old and new values, right? We will be selecting old and new values. Now we can convert this one by one, like 1 to 1, 2 to 1, and so on. But better we should use the range. So what is our first range? That is from 1 to 4. Okay. So in old value is from 1 to 4, and we are developing a new category with the title 1. So we will be converting the range 1 to 4 into a new variable that is a willing cat with the category number 1. So 1 to 4 would be converted to 1. Then we have from 5 to 7, the second range, and the corresponding value would be 2. So we have input for 5 to 7, and here the value is 2, and we will be clicking the add. So 5 to 7 would be converted to 2. Then the next one is from 8 to 11. So 8 to 11. So this is the input category or the old values, and we will be having a new value as 3. So from 8 to 11 would be converted to 3, and we press add. So here 1 to 4 is being converted to 1. 5 to 7 would be converted to 2. 8 to 11 would be converted to 3. Okay. And we will be pressing OK. Now you see a new variable, categorical variable, willing cat has been created. Now, if we don't require these zeros, so we will be decreasing the number of zeros. Okay. So as you see, now zeros are not there. And we will be defining the values also because this is a categorical variable. So one is actually the low willingness, and two was medium willingness, and three was high willingness. right? We will be adding. So we are defining all these variables and save the data. Okay. Now we will be running this test. So we go to analyze. Then we go to this descriptive part where the cross tab is available. So from descriptive to cross tab, just a moment. So we go to analyze, then we go to descriptive statistics. In the descriptive statistics, we have cross tab, cross tabulation, right? So here in the rows, we will be selecting the familiarity attribute or familiarity variable in the rows and willing cat into the column part. Right? Now, for the demonstration purpose, I will be using display clustered bar charts. Okay. And then we go to the exact, we are not using this. We go to statistics and here we will be having this chi-square value. Okay. And for the cells, we will be having these observed values, right? And if you require the percentage also, then you can have observed percentage. If you don't require, you can ignore this, right? And if we press OK, right? So this is the cross tabulation that I was mentioning. On one side, there is familiarity, and that is on the row side. And on the column side, we have willing category, right? Like this 63 is having no familiarity with AMC and showing low willingness. In the same way, if we go to this part, that is 100 are having um, more than 3 years of familiarity, means high familiarity as well as high willingness, right? So this is the cross tabulation that I was mentioning. The first part is related to uh, the values, and the second part is related to percentage with respect to rows. That's why all the rows sums are for the percentage, we will be having 100%, right? So this is being demonstrated here in the bar chart also. This is the cluster bar diagram that I have already used when we are discussing the visualization part. This this is no experience cluster. This is less than 3 years experience. This is more than 3 years experience. Means this is low familiarity, this is medium familiarity, this is high familiarity. And on here, we will be having the three category related to willingness. This blue bar is the low willingness, this red bar is the medium willingness, and this green bar is the high willingness. Now, if we compare this blue bars actually represent the low willingness. So as we go from no experience to high experience, this blue bars decreases. Means we can say as the familiarity increases, the low willingness decreases, right? Remember what I am saying, that as we go from no experience to more than 3 year experience, and if we observe this blue bar, so blue bars are representing low willingness. So as we move from this side to that side, so this blue bar's length decreases. Means as the familiarity increases, the low willingness decreases. Means the inverse relation, right? Related to low willingness. Now, there is not much difference related to the medium willingness, that is the red bar. But if we look for the green bars, that represent the high willingness. So initially, this is the length where we are having no experience. Here we have medium experience, and here we have high experience. So as we go from no experience to high experience, the length of these green bars increases, means high willingness increases, right? So um, on the negative side, there is an inverse relation, and on the positive side, we have a direct relation or the positive relation. So we can say that with increase of familiarity, it appears that the willingness increases, means they are actually related. And we will be examining this through the test statistics that we have discussed. So again, I'm repeating this for the green bar. So as we move from no experience to high experience, the length of these green bars increases. Since the length increases, so high willingness decreases, right? So this is just a demonstration of what we are going to do. But in order to confirm through the test, we will be discussing the chi-square test uh, statistics and the corresponding p-value. So as you see, this is the chi-square value that we have discussed, and this chi-square value appears to be high. This is not the zero value, and this is the p-value. This is p-value is 0.014, which is less than 0.05. Means we will be rejecting H naught. Rejecting H naught means their independence is being rejected, so we will be rejecting H naught, right? Means we can say the variables are related. This I will be noting down on the on my PPT or the whiteboard, right? Remember these two values, 12.492 and 0.14. Okay. So here, as we have discussed in this situation, right? So as per the output, this chi-square value from the sample, that is the chi-square stat value, is 12.492. So it looks to be a high value. And correspondingly, its p-value, which is asymptotic significance, is 0.014, which is less than 0.05, right? So we would be rejecting H naught. Rejecting H naught means we are rejecting that gender and sorry, we are rejecting for this case that they are related. Okay, right? So here I will be putting this for this case only. So now we will be writing that again because the earlier one was an example. So here the two attributes, that is the familiarity and willingness, are independent. Okay. And H1 would be familiarity and willingness are related. Okay. So here, as we have just discussed, the chi-square value from the sample or chi-square stat value is 12.492, and the corresponding p-value, which is 0.014, which is less than 0.05. So we would be rejecting H naught. Means we are rejecting this, we are rejecting independent. It means familiarity and willingness are related. And as per the discussion of the sample values, and this relationship is a positive relationship. So we can say as the familiarity increases, the willingness to buy this mutual fund would increase, right? So they are having positive relationship. Okay, right? So what is the message for the AMC? That AMC can make use of the familiarity aspect with itself to the investor so that they will be showing high willingness um, to buy the AMC mutual fund that is being introduced, right? So this is the cross tab that I have just introduced. Now, I will be introducing one more related concept that is known as layering in cross tab. This is layering in cross tab. Okay, layering in cross tab means we will be introducing one more aspect in this analysis of relationship in cross tab analysis. Like here, in this case, we are considering the relationship between familiarity and willingness. Remember when I have introduced the case, then I have shown you that this data is related to the three company size executives, right? So here we will be making use of that variable with respect to company size of the executives. I will be showing you again, right, of the executives. And there are three company sizes. One is small, the other one was medium, and the third one was major corporation. Means we will be repeating this cross-tab analysis separately for small, medium, and major, just to check whether the aspect that we have discussed overall is applicable in the same manner to the three categories or there is some difference, right? So this concept is known as layering. And this variable, that is the company size, is known as the layering variable or the layering attribute that I will be introducing here. Okay, so here I have mentioned that at present we are examining the relationship between familiarity and willingness. And but here I will be introducing one more layer, that is, right, company size also, right? So I will be introducing the three company size, that is small, medium, and major. Means in short, we can say that we are performing this cross-tab analysis separately on small, medium, and major, right? One method is you can always use the filter, but for that you have to run the analysis three times. But here, entire thing would be done in one, right? So accordingly, we select the variable, right? So this is our data set. I'm just repeating the path uh, or the link. We go to analyze, then we go to the descriptive statistics, and in the descriptive statistics, we will be selecting crosstab. These two are the variables, and this is the layer. We can have more than one level of the layers also. And it is very useful in all the data sets which are having some demographic characteristics, especially in the survey data, because in the survey data, we collect information related to a number of demographic variables, and all our analysis would be subdivided into those categories. So we will be using this company size as a layer one, right? And we will be pressing OK. So now, as you see here, this is a cross tabulation. Remember, we have a single cross tabulation for entire data set. Now, we have three cross tabulation, for one for small company size executive, other for the medium, and the third one for the major. And this is for the total that we have done earlier also. In the same way, we have this clustered bar chart for one subsegment, that is a small company size executive. This is for the small medium company size, and this is for the major corporation. Now we will be discussing these chi-square test values. Okay, and as you see here, for the small, this p value is 0.303, which is greater than 0.05, right? Greater than 0.05 means we do not reject H naught. We do not reject H naught. Means they are independent for small company executives, right? In the same way for the major also, we look for this p value. P value is 0.703, which is greater than 0.05. So here also, we do not reject H naught, means here also they are showing independence, right? So we can say that the relationship between familiarity and willingness does not hold between small and major. Means in small and major company, for small and major company executives, they are showing independence. But if we go for the medium one, so this p value is 0.004, which is less than 0.05. Less than 0.05 means we reject H naught. Okay, means they are showing relationship. Means the relationship between the familiarity or the positive relationship that we have discussed earlier doesn't hold good across all the sub-segment, across all the segment. It holds good only for the medium segment, right? So these results I will be writing down on the whiteboard so that there would be higher amount of clarity. Okay. So here, as we look for this output, so we will be having the first one as the small company executives. The next one is for medium. And the last one is for, here last one is for major. For the small, our p-value, that is asymptotic significance, is 0.303, which is greater than 0.05. So we do not reject H naught, we accept H naught. We do not reject H naught, means familiarity and willingness are independent. Means there is no point of making use of familiarity for increased willingness for small company executives. This is for small. The next one is for the medium. Here the p-value or asymptotic significance is 0.004, which is less than 0.05. So we reject H naught, right? Means familiarity and willingness or willing category are related. Since they are related, so it means familiarity may have some impact on the willingness. So here, for the medium company executives, there is a point of using familiarity in order to increase the willingness. Now, if we come to the major corporation part, here the p-value or asymptotic significance as being mentioned in the output is 0.703, which is greater than 0.05. So we do not reject, right? It means familiarity and willingness are independent. Okay, means there is no. So we can say that actually by the layering, we got the additional information that the linking of familiarity and willingness happens to be only in one segment of the business executives, that is the medium, right? So so if AMC wants to make use of familiarity, so to increase the willingness, they should try only for the medium. There is no point of trying on small and major, right? So this is about the layering that we use for the cross-tab. You can further increase this layering with respect to other attributes also, since we have more than one labels are available. So this is all about cross-tab analysis or chi-square test of independence. Hopefully this is clear to all of you.